Okay, the last part of the second titration problem, 2D, finds us looking for the pH after adding 100 milliliters of acid. Now, first of all, just using logic, I know I'm at the equivalence point. If adding 50 milliliters got me halfway to the equivalence point, then adding 100 would get me all the way there. So it is possible to go through this starting out the same way we did. However, you'll come into a problem because when you figure out that the 0.150 liters times 0.500 molar equals 0.075 moles, then we get to the fact that 0.100 liters times 0.750 moles per liter equals 0.075 moles. So the moles of NH3 are matched perfectly by the moles of H plus. Every last one of these is turned into an NH4. There's 0 left. So that means that I can't use the HH equation. So what does it mean when I've turned them all into NH4? It means that I have 0.075 moles of NH4 plus, and I have that in 0.250 liters. That's my total volume, all added together. So that means I can solve this and I can say that my concentration of NH4 plus equals the moles of NH4 plus divided by 0.250. So my concentration of NH4 plus happens to be, oh, I just had it, 0.30 molar. Now, since all of the NH3 is gone, all right, it's totally been reacted. And because I've been adding acid, I have not been accumulating OH. So this means at this point, the equivalence point, I only have NH4 plus in water. And as the conjugate acid of a weak base, it is a weak acid, a really weak acid. So if I put NH4 plus into water, it's going to make NH3 plus hydronium, or H plus. This is an acid dissociation. So Ka equals concentration of NH3 times the concentration of hydronium, all divided by the concentration of NH4 plus ammonium. Now I know this number. I figured it out. These two have to be the same. They're both X, because every time it happens I get one of each. So all I need to be able to solve this is to figure out what is Ka. Well, to find Ka, and on the side here, Ka times Kb always equals Kw. So Ka equals Kw divided by Kb. So Ka equals, Kw is always 1 times 10 to the minus 14. It never changes. Kb was 2.4 times 10 to the minus 5. So Ka, the reverse of my base dissociation, happens to equal 4.17 times 10 to the minus 10. So I have a number for this. And I have a number for this, and both of these are X. So 4.17 times 10 to the minus 10 equals x squared over 0.30. X will equal the square root of this Ka, 4.17 times 10 to the minus 10, times this concentration, 0.3, which means X is 1.12 times 10 to the minus 5. X is the concentration of hydronium. Concentration of hydronium, I can find pH from that. pH equals the negative log of the concentration of hydronium ion, or hydrogen ion, same thing. So that's this, the negative log of 1.12 times 10 to the minus 5. My pH equals 4.951 at the equivalence point. Ta-da! You own it!